Okay, so let's take a look at converting simple 4-bit binary numbers into decimal numbers. Now let's write a random 4-bit binary number here on the paper, 1011. It's 4 bits because there are 4 values, either 1 or 0, 4-bit number. And the first thing you want to do when you're converting from binary to decimal is write the place values of the number. And in fact, this is the method for converting any number back into its decimal equivalent. So we put on the place values 1, 2, 4, 8. If it was more than 4 bits, we'd keep going up into 16, 32, 64, and 128. And then what we do underneath is we times whatever the value in the number is by its corresponding place value. And then we add each of those up in turn. So we do 8 times 1 plus 4 times 0 plus 2 times 1 plus, you guessed it, 1 times 1. Okay, I'll just put underneath those what those values are. 8 times 1, 8, 4 times 0, 0, 2 times 1, 2, 1 times 1, 1. We add them all up together. 8 plus 2 is 10, plus 1, 11. There we have our answer. Now you'll notice there's a few things I did there that probably you won't have to do. You'll notice anytime you times the place value by a 0, you're going to get 0. So you may find it easier just to go, okay, let's just look at the place values which have a 1 in and ignore any that have a 0. And we know that if it's got a 1 in, it's not going to change this number at all. 1 times 8 is still 8. 1 times 2 is still 2. So you may find it easier to, instead of doing it out this way, go, right, well, this is just 8 plus 2 plus 1, which is 11. The reason I'm showing you this method is that when it comes to hexadecimal to decimal conversions, this long-winded way will work every time, but it does take a little bit longer. So let's do another example. In fact, see if you can figure this one out first. Okay, first thing you do, put the place values on top, 1, 2, 4, 8. Look at the ones that have a 1, and there's just 1, so this value is 8. Let me do one more. 4-bit binary number, have a go. Okay, we put the place values on, and then we go, each digit that has a 1, we go through in turn. 1 lot of 8, 1 lot of 4 is 12, 1 lot of 2, 14, 1 lot of 1, another 1 to make 15. So we have 8 plus 4 plus 2 plus 1, and that gives us 15. Let's look at a slightly more complicated example where we do an 8-bit binary number. So there are 8 values in the number. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Again, first thing we do, put the place values on the top, going up in powers of 2 each time. You'll notice it goes all the way up to 128 this time. And again, we're doing the same thing as before. You may even find it easier to circle the place values you're interested in, the ones that have a 1 next to them. If it helps you, that's another method. 128 plus 16 plus 4 plus 2 plus 1. You can do it this way, long addition. 8 plus 6, 14 plus 4, 18, 20, 21. 2 plus 1 plus the 2 carried gives you 5. And then the 1, there you go. Your final answer being 151. Now, what about this number here? Now, in fact, this number could mean any different things. How do we know if this is a binary number, 1, 0, or the decimal number 10? So there's a little thing you can do to make it very clear, and I'd recommend you do this when doing any sort of working out. And that's by adding a little number in the bottom right-hand corner. If it's a binary number, you put a little 2, because it's base 2. binary. And if it's decimal, you put a little 10.